Good morning, everyone. My name is Isabella Namganza, and today I'm going to be talking about fundamentals of artificial intelligence in relation to my restaurant management system project that I'm doing. So for history, trends, and future, Alan Turing in his landmark paper was the first to explore the possibility of creating machines that could truly think and reason like humans. His work laid the theoretical groundwork for what is currently known as AI. So, an important discovery in the early days of AI research was the realization that intelligence requires knowledge. AI is not all about algorithms. It's about giving those algorithms the knowledge they need to make intelligent decisions. Think of it like a human brain. Yeah, we cannot solve a problem we know nothing about. AI is the same way. Then to like solve an AI problem or like to tackle an AI problem, we must follow a structured approach. This involves like four key steps. That is defining the problem, analyzing it, representing the task, knowledge, and choosing the best problem solving technique. This systematic process is what allows us to go from a theoretical concept to a practical solution in the real world of artificial intelligence. So our third slide covers heuristics, which are rules that help an AI estimate how close it, it is to a goal. For a heuristic to be reliable, it must be admissible. This ensures we find the best solution. There is a trade-off between the heuristics accuracy and how long it takes to complete. We see this in search algorithms like best first search, which uses a heuristic to guide its way, whereas an algorithm like hill climbing might get stuck and fail to find the best possible solution. Here we are going to cover three concepts for AI problem solving. First, we have and/or graphs. These break down a large problem into smaller sub problems that all must be solved. Then AI uses game trees to find the best move in a game by exploring all possible future moves. Yeah. Then for complex games like chess, alpha beta pruning is a critical optimization technique. Yeah, it like drastically reduces the computation needed to search that game tree. So here I'm going to talk about knowledge representation. This is how AI systems basically like store and use information. It is like built on the idea of symbolic systems where intelligence comes from a machine manipulating symbols. We use formal logic as a common way to we use formal logic as a common way to like represent this knowledge. Yeah. And overall goal is to create a relationship where symbols stand in for real world concepts, allowing a computer to process information efficiently. So here we're going to explain how to use first order logic for AI reasoning. So this process begins with formalization, where we use logic to determine the truth of a statement, which we call satisfiability. So our knowledge is built on fundamental truths called axioms, and AI performs reasoning by applying mathematical proofs to these facts to deduce new information. So here, resolution is a core method of interface in AI logic that proves a statement by showing its opposite is false. Paramodulation is a specified rule, basically makes resolution work within qualities, while resolution is a complete proof. system. Its basic search strategy is often very, very inefficient. So here, under reasoning, under uncertainty, we use probability theory to handle situations where we don't have complete information, which is a key to limitation of traditional logic. Bayesian updates allow an AI to refine its beliefs by incorporating new evidence. Utility theory helps the AI decide what to do, weighing the desirability of an outcome against its probability. So basically, in this slide, we are talking about AI planning, which is the process of creating a sequence of actions to achieve a goal. STRIPS is a common planning system that uses action schemas to define problems. Then goal stack planning is a method that breaks down goals into sub-goals, though it is not guaranteed to find a solution. Finally, situation calculus is a logic-based language used to reason about how actions change the world. Yeah. So here we're going to basically look at how AI handles planning in complex environments. Hierarchical planning breaks down a large problem into smaller tasks. For uncertain situations, we use a framework called Markov Decision Processes, that is MDPs. Within this framework, value iteration is a key algorithm for finding the best course of action. So machine learning, ML. As a field of AI, this allows computers to learn from data without explicit programming. Its rapid growth is due to new algorithms and the availability of vast amounts of data. ML is like a subset of AI that automatically creates analytical models and is now used in many industries like healthcare and finance to solve data intensive problems.